this part because this is the part that I would like to be on record. Discussion about this table list.
Sir,
Yes.
আমরা কি পেপার 3 করব না তাইলে?
স্যার আমি মাত্র জয়েন করেছি স্যার এই প্রিন্সিপাল 1 2 3 আর 4 গুলোতে মানে এটা কি স্যার এটা লাইক এটা কোনগুলোতে এটা অ্যাপ্লাই করে এগুলা
These are the marking basic marking principle for paper 4 question paper checking. I'm going to discuss what these things mean so that you have a general idea that how the examiners are going to mark you for, so that you know what to write and what not to write. Paper 3 আমরা করব কিনা? This is actually one of the most difficult questions that I could possibly attempt to answer. For the situation that we are at, I would say no. But if you ask me that by heart and soul, would I want the kids to be accustomed to the apparatus and everything? The answer is a solid yes. But it is possible to bypass the P3 course up to your O levels. But whenever you get to your AS level, you have to handle with your equipment. So truthfully speaking, if you consider the health hazard that is associated with mingling people in a closed group situation and the opportunity of paper 4 being presenting itself that we have right now, if you ask me, the safer option for you kids is to go for paper 4 in your O levels and take some additional pressure in your AS level. Hopefully COVID goes away by then, or we have a good cure, or actually at least the graph gets flattened, for those who know what I mean. Then we can also get our hands on with the equipments. It would have been a much better, but a better experience and better understanding for you kids if you could actually work with the equipment, because as the CA people did describe, and I also agree with them, that laboratory course is not an alternative for the P4. P4 is an alternative question paper than P3, but laboratory course should be taught to all the levels kids, irrespective of whether they're going to appear for P3 and P4. I totally agree with them. But given the situation that we are at, it's not very, I mean, if you ask me, it doesn't look very hopeful. Could I answer your question?
Yes, sir.
It's not good news, but that's the best news we have. Okay, I'll take questions from these bullet points that you can ask me. Go ahead, shoot. কোন পয়েন্টটা বুঝো নাই?
Principle 4.
কোনটা?
Principle 4, sir. Generic marking principle 4.
Generic marking principle 4. Rules must be applied consistently. Example, in situations where candidates have not followed instructions or in the application of generic level descriptors. আচ্ছা, সেটা হচ্ছে rules must be applied consistently means if there is some specific condition for a certain question to be checked, and the standard of marking should not vary from one paper to another paper. For example, মনে করো হচ্ছে কোন একটা সার্টেন P4 পেপার চেক করার সময় কোন একটা স্টুডেন্ট স্টপওয়াচে স্পেলিং মিস্টেক করছে, ঠিক আছে, বাট স্টপওয়াচ, the word itself was not a key word for that question. It was asked to describe how the measurements for that experiment could be made. So এখানে হয়তো length measurement করার জন্য মিটার রুলে মেনশন থাকতে হবে, স্টপওয়াচে মেনশন থাকতে হবে, but somehow let's say misspell the word stopwatch. আর মনে করো আমি একজন এক্সামিনার হিসেবে একজনের কপিতে মার্কস দিই নাই, স্টপওয়াচের স্পেলিং মিস্টেক করছে, আমি ওই 1 মার্ক তাকে দিই নাই। আবার পরের কোন একটা কপিতে গিয়ে আমি অন্য কারো একটা কপিতে যে স্টপওয়াচের সে মিটার রুলের মনে করো স্পেলিং ভুল করছে, তাকে আবার মার্ক দিছি। এটা করা যাবে না। I must be consistent in my checking, following the same standard for all the students' copies throughout. That's what this means. বুঝছো কি বলছি?
জি স্যার।
আচ্ছা, এই দুটো প্রপার্টি ভালো করে পড়ো। Marks are not deducted for errors in your description for any experiment, not mathematical. This is not for mathematical, this is for descriptive questions. If you mess up some expression, you are not going to be having deducted marks. If you forget to write about something, you are not going to have deducted marks. মানে অ্যাডিশন, দিস মিন দ্য অ্যাডিশনাল ডিডাকশন। অ্যাডিশনাল ডিডাকশন মানে কিরকম, মনে করো হচ্ছে একটা সার্টেন পয়েন্টের মার্ক স্কিমে একটা সার্টেন কোশ্চেন মনে করো 3 মার্ক আছে, মার্ক স্কিমে ওই কোশ্চেনের জন্য 3টা পয়েন্টস লেখা আছে, তুমি ওই 3টা পয়েন্টের মধ্যে 2টা পয়েন্ট লিখছো, একটা পয়েন্ট লিখো নাই, দিস ইজ ডেফিনেটলি ইউ আর গোনা লুজ 1 মার্ক। But let's say you forgot to write something that might be relevant for the experiment but was not mentioned in the mark scheme. For that kind of things, you will not be losing mark. For errorful information, you will be not losing mark. However, this is important. Answer should only be judged on the quality of spelling, important, punctuation and grammar when these features are specifically assessed by the question as indicated by the mark scheme, which means মনে করো কোন একটা সার্টেন কোশ্চেনের জন্য একটা ডিরেকশন ওয়ার্ড খুব ইম্পর্টেন্ট। ফর এক্সাম্পল, লেটস সে ইন আ সার্টেন কোশ্চেন they say that there is a set square. To take a good measurement of this length, the set square have to be moved in which direction? So মনে করো তোমার লেফট or রাইট বা আপ or ডাউন বা টুয়ার্ডস এ or টুয়ার্ডস বি, এরকম একটা আনসার লিখতে হবে। এখন if the correct answer কেন পরে ক্লাস দিচ্ছি। So if we are trying to get, if the correct answer response for this answer is let's say towards A, and some students do not write the word towards, but in the mark scheme towards A, these two things towards A was underlined, and if someone do not write towards A, only write A, they're going to be losing mark. This is the part that they mean that grammar is important. It means, I mean, you don't have to be like Shakespeare level or like say super grammatically correct answer. You can always write your answer in phrases as long as they make sense, like I've always taught you. But if your sentence construction or paragraph writing is such that it's ununderstandable, for example, if some kids write without any full stops, write all of their paragraphs in small letters, there is no capital letter to represent where the sentence starts, where the sentence finishes, then that's practically what, garbage, if you ask me. That kind of poor grammar are not gonna be marked. You're not gonna get marks for that. Having regular grammar, regular punctuations, and obviously quality of spelling is very important. That's what I just said for the part of stopwatch or meter rule thing. Spelling mistakes are very, very important. You shouldn't be doing spelling mistakes. এগুলোর উপর বেস করে তোমাদেরকে মার্ক দিবে। However, this means the meaning should be unambiguous. This is pretty important. এই জিনিসটা elaborate করি। You cannot write contradicting information in a descriptive answer and expect to get mark for it. মনে করো সার্টেন একটা জিনিসের ডেসক্রিপশনে তুমি ফার্স্টের দিকে একটা জিনিস করবা বলে লিখছো, ঠিক আছে, you describe that I'm going to do this thing or I'm going to measure this thing, or I'm going to align this meter rule vertically, or I'm going to use a plumb line to do this thing. আবার পরে গিয়ে তুমি বললা যে so that there is no additional friction we should not use the plumb line. ভার্টিক্যাল করার জন্য তুমি শুরুর দিকে বলছো প্লাম লাইন ইউজ করছো, আবার প্লাম লাইনের ফ্রিকশনের জন্য যাতে এক্সপেরিমেন্ট হ্যাম্পার্ড না হয় লাস্টের দিকে তুমি বলে দিলা যে টু অ্যাভয়েড ফ্রিকশন উই শুড নট ইউজ এ প্লাম লাইন। there are ways to avoid friction even when a plumb line is used. You can make the equipment spaced up and use a set square to take your measurement. That's an effective way to go for it. But let's say if you propose that to avoid friction we are not going to use a plumb line, whereas you mentioned at the beginning that we're going to use a plumb line, তখন তুমি ওই প্লাম লাইন ইউজ করে ভার্টিক্যাল করার যে মার্কটা ওই মার্কটা পাবা না। These are what we call contradicting information. Your passage should not have contradicting information. The whole thing should be unambiguous. It should not give the examiner a perplexing idea or a confusing idea or a bidirectional meaning of something so that they would not give you the mark. বুঝা আছে কি বলতেছি? unambiguous কথাটা মানে বুঝা গেছে?
Yes sir.
Your answer should be inherently coordinated. আর হাফ মার্ক দেওয়া যাবে না, হোল মার্ক দেওয়া যাবে, এই জিনিসগুলো জানো। আর হচ্ছে এখানে একটা জিনিস যেটা বলছিলাম সেটা হচ্ছে যে marks are awarded for correct or valid answers as defined in the mark scheme. However, এটা হচ্ছে বেসিক জিনিস, এটা তুমি অলরেডি জানো। However, credit is given for valid answers which go beyond the scope of the syllabus and mark schemes, referring to your team leader as appropriate. Let me elaborate one of these things what is meant. তোমাদেরকে সামটাইম সিলেবাসে পড়ানোর সময় আমি একটা জিনিস বলি যে solid boundary of the syllabus and dotted boundary of the syllabus, ঠিক আছে? If you refer to some equipment use that you did not read in your syllabus but you know this thing works, you can also get this mark. For example, for the measurement of time, you have only learned the use of a stopwatch, right? Correct.
Yes, sir.
Yes.
In your paper 2 or paper 1 revision, you have only used that the equipment that you use is a meter rule or vernier calipers or microscope for small dimensions. Or in longer cases, we can go for measuring tape, or we can also go for trundle wheel. Now, in some experiment, there is a length measurement device in every car which measures how many kilometers it have run. Do you kids know what this device is called? Every car has a kilometer measuring device in them.
Speedometer.
It's called pedometer, exactly. P-E-D-O-M-E-T-E-R, pedometer. Now, some of you might have known this name, some of you might not have known this name. In a certain applicable experiment, if you write that we use a pedometer to measure the distance from point A to point B. For example, let's say if you are trying to measure doing an experiment for the sound experiment using the blast gun method, where the distance between the shooter and the observers have to be pretty significantly large, about at least 500 meters apart, for the idea of for minimizing the effect of reaction time. For measuring that kind of a long distance, using a measuring tape is good, using a trundle wheel is good. But if someone writes we use a pedometer to measure that up, these kids are also going to get that mark. This is something that is beyond the scope of syllabus, but it is valid and correct. Do you guys understand my point? বুঝা যাচ্ছে? এখানে ওরা একটা জিনিস বলছে যে credit is given for valid answers which go beyond the scope of the syllabus and mark schemes, referring to your team leader as appropriate. Referring to your team leader as appropriate, এই কথাটা মানে হচ্ছে whenever the CIE actually dispose of the paper to certain people, the way the whole I mean, as far as I know, I might not know the whole process, but so far I know that the way they distribute the paper is that they set out a team leader for a certain number of examiners. Let's say there are 10 examiners and they have one team leader. The team leader is also one of the examiners. So they are each checking, let's say 200 copies. So together they are checking 2000 copies. The team leader is the person who is gonna work as for their answering person, who is gonna collaborate with the principal examiner and transfer the information directly to the examiner. So that all the examiners would not be communicating to the principal examiner directly. So if there is a certain confusion that for a certain question there is a correct answer that mark sheet did not propose, but a teacher really want to give the student a mark where the student should get a mark because it was relevant, then they should contact with their team leader and let them know that this thing was not mentioned in the mark scheme, but it goes beyond the scope of the syllabus, but this is correct and valid answer, so I'm giving marks to this. So that this team leader can transfer this information to the principal examiner. They can consider this information, and if they feel like that this is a valid proposition, they can distribute this information to the other team leaders and other examiners as well, which means if anyone else finds this information, they should also give the marks to those kids, so that this is a general uniform marking standard throughout the whole checking process. So that's what it means for the reference of the team leader, that if a teacher is about to give a mark to a student beyond the scope of the mark scheme, they should discuss it with their team leader so that this information is generally available to the other examiners as well. বুঝা গেছে কি বলছি?
Yes, sir.
Yes, sir.
আচ্ছা, anything else from these things or 5 or 6?
স্যার
Sir.
Yes.
এটা কি শুধু অ্যাপ্লাই করে এই এর জন্যই, মানে P3 বা P4 এর জন্যই, নাকি এটা পুরো ফিজিক্স সিলেবাসের জন্য অ্যাপ্লাই করে, যে মার্ক স্কিমের স্কোপের বাইরেও যদি হয়, বাট এটা যদি অ্যানসারটা যদি রং না হয় তাহলে এটার জন্য মার্ক পাবো আমরা? শুধু P4 এর জন্য?
As far as I can say, yes, because I have never seen this kind of marking principle in paper 2 or paper 3. Just okay, never mind. Because you are asking me, I can look it up. Let's say if I go to the mark scheme for May June 18 and try to look at for paper 2 or paper 3 questions. As far as I have seen, they don't exist for those. But just to be sure, I'm gonna have a look. Let's say we go for the mark scheme for paper 21. Yeah, they apply for those things as well. Yep. May June 28 is they have these things as well. Yep. Yeah, I'd say yes. You see, this is also included in the mark scheme. Then starts the actual mark scheme. It goes in these tables. The answer to your question is solid yes.
স্যার রুল 6 আছে না রুল 6
Yes.
ওইখানে মার্কস কি জানি একটা বলতেছে দেখেন মার্ক শুড নট বি অ্যাওয়ার্ডেড উইথ গ্রেড কি মিনিং করছে
আচ্ছা, marks should not be awarded with grade thresholds or grade descriptors in mind. এটা মানে হচ্ছে যে whenever an examiner is checking the copy of an examiner of an examinee, the teacher should always give the mark, absolute mark that the student is deserving. The teacher should not keep in their head that what is the grade threshold of this year is going to be, or what was the grade threshold of the last year was, or am I giving too many students a star in my bundle, or am I giving too many students C or D in my bundle. This kind of grading variability should not be in their mind. A teacher should always give a student what they are absolutely deserving to get. মানে জিনিসটা এরকম না যে let's say a teacher receives 200 copies, out of those 200 copies, if it happens that 150 of the students got about a star amount of raw marks, then the teacher gets a bit what can I say, bit tensed, and it might feel like that he or she is taking it too mildly, and he or she goes harsh on the remaining 50 papers. This kind of things should not happen. Every student should be judged from zero ground. বুঝছো কি বলছে?
জি স্যার
So this was the part that I really wanted to discuss with you kids before you start working this. Yeah, Fardin, yeah, go ahead. Bolo. You just raised your hand.
sir.
Acha, sorry. So yep, that's pretty much it.
স্যার
Ye bolo.
আজকে রিভিশন না দিয়ে আজকে ডিফরমেশনটা স্টার্ট করে ওটা পড়ানো হয় না, তো ওটা পড়ার পর ট্রানজিস্টর যদি করতাম।
তোমাদেরকে ইলাস্টিসিটি করাই নাই?
না স্যার।
Sir.
কি বলো? ইলাস্টিসিটি চ্যাপ্টারে তো পড়ানোর মতো কিছু নাই রে বাবা। আচ্ছা 15-20 মিনিট লাগবে, আচ্ছা 15-20 মিনিট তোমাদেরকে পড়াই, সমস্যা নাই।
Sir, static electricity nodes কি দিবেন with magnetism?
I hope I have them, but I have to look. দাঁড়াও দেখতেছি আমি। আমার স্ট্যাটিস্টিক্স নোটস বানানো আছে কিনা। বানানো না থাকলে খুঁজে বানাইতে হবে। থার্মাল রেডিয়েটিভিটি, ইলেকট্রনিক্স, ওয়েভস, ম্যাগ, থার্মাল রেডিয়েটিভিটি, স্ট্যাটিস্টিক্স নোটস ক্লাস 9 এখানে নাই, বাট অন্য কোথাও থাকতে পারে। So we might as well take a hack at the elasticity chapter.
Sir, recording.
হ্যাঁ, রেকর্ডিং আবার স্টার্ট করছি। So not to cheat, but rather to have me a better guidance on what I'm about to tell you, I'll pull this up. Wow. This is which year? Awesome. Good.
Yeah, we started the recording. So,
First of all, by applying force, we can do three things to an object. We can move an object, we can turn an object, or we can twist an object or deform an object. So this is the first thing that I was discussing. And then comes the type of loading that we can say. Then comes the Hooke's law. Hooke's law goes like this: applied force is directly proportional to extension. আমি এখানে এক্সটেনশনের মধ্যে আনলাইন করার কারণ হচ্ছে, the reason I underline this thing is that This is the way your syllabus proposes this Hooke's law, but this is not essentially extension. This can be compression as well. If you compress a spring, it will also follow Hooke's law if it is within the limit of proportionality. So Hooke's law এখানে একটা পার্ট আমি লিখি নাই ভুলে, সেটা হচ্ছে within limit of proportionality applied force is directly proportional to Hooke's law proportional to extension. So within limit of proportionality কথাটুকু শুরুতে লেখা লাগবে. This is sort of the precondition for the Hooke's law to be applicable. Pretty much similar to Ohm's law. Ohm's law একটা precondition আছে, at constant temperature voltage is directly proportional to current. If you guys remember, মনে আছে? Sorry, current is directly proportional to voltage. At constant temperature, current is directly proportional to voltage. Similarly, Hooke's law precondition হচ্ছে within the limit of proportionality, applied force is directly proportional to deformation. Deformation is the more generic word, but তোমাদের syllabus এটাকে extension হিসেবে define করছে, so it's better to write extension, but you should remember in your mind that is applicable for extension and compression both. So এরপর আমি we can have two type of deformation. We can have elastic deformation, which is reversible, and we can have plastic deformation, which is irreversible or permanent. What does these two mean? It's basically pretty simple, is that if you bend an object or if you deform an object, and after you remove the force, if the object completely gets back to its original shape and size, basically dimension, then that deformation is what we call the elastic deformation or reversible deformation. And plastic deformation is whenever we bend or deform an object in such a way that after removing the force, the object does not completely come back to its original shape. So it's going to try to come back to its original shape, obviously, but it will not be able to come back completely to its original shape. That's what we mean as plastic or reversible deformation. Typically, you can have a lot of example for rods and everything, but one simple example that I always like to discuss is a piece of paper. Let's say if you consider a normal flat piece of paper, if you roll it a little bit, this is a shape change. That is a type of deformation. Then if you just let it go, the paper will naturally come back to its original shape. So that's elastic deformation or reversible deformation. Then if you fold a paper and make a crease, which means along the folding line, if you actually press and pull it down, you make a crease on the paper. After you remove the force, the crease will remain on the paper. That's plastic deformation along that line. So that deformation that you could not get rid of, even if you fold it, this line would not actually perfectly disappear. You can make it wet and do a bit of ironing. Maybe this line would become maybe a bit dull, but you can never get rid of this crease line altogether. So that's the type of deformation that we call as plastic deformation or irreversible deformation. So what do we have after? This example, I was applying a load perpendicular to the axis, because if this is a rod, the x would be horizontal. So here I was describing some experimental setup for that. How can we actually measure the deformation for an object, or plastic deformation and reversible direction? And here we have force versus extension. So we could plot this graph over here. Okay, so the amount of deformation that any object gives, if you plot the graph of force versus extension for object's deformation within limit of proportionality, we're going to get a very perfectly straight line that passes to the origin. This means that whenever no force is applied, the deformation of the object will be zero. The further forces that we apply, the object is going to get more and more deformed. You have to understand this x represents the amount of deformation, and the gradient of force versus extension graph, Fs graph, is defined as spring constant, which is represented by the letter k, small k. Now, although we call it spring constant, but this graph is not exclusively applicable for springs. This can be equally applicable for a wire as well. So even if you have a piece of wire that runs over a pulley with a setup, maybe something like this, হ্যাঁ আমি কি খুঁজতেছি কি পাইলাম হ্যাঁ got it. Yeah, so this is another this can actually work as an oscillator. No, this is not good. Yeah, this is the figure that I was talking about. It's a good figure. Have the stuff that I want. So if you have a look over here, that we have a G clamp over here, and we have a clamp this clamp a piece of wire over here, and this is the piece of wire that we are working with. This is the G clamp with on the table, and then we have a polystyrene board over here, or it can be a sand tray, or it can be a some sort of soft foam cushion, so that even if by some mistake we apply too much load and the string breaks, this falling masses does not damage the floor or our feet. So we should have some sort of cushioning mechanism over here, preferably. And this is the pulley that is clamped on the side of the table, and this is the straight wire that runs over the pulley, and here we are gonna add load. So we're using the weight of this load to extend this wire. And the reason we have a marker over here, this is a small piece of taped piece of paper, which is a sharp corner, which is touching the meter rule underneath. So the beauty of having this thing is that you can have a proper measurement of this part of the wire. And it is not going to roll over onto the pulley side. So that's why we have it over here. Either we can do this, or in other cases we can also do the experiment in this fashion as well, where we can have the ruler vertically, so that this entire length of the ruler would be this thing. So in this case we are not going to get the original length of the wire, or the original length of the wire will be unknown, but we can very easily measure how much extension do we get for the application of every load. One interesting important part to perform any of this experiment, whether this is a spring or this is a wire, is that for every value of load, we should get two different readings of the on the meter rule. They don't have to be different, but we should get two readings. I mean, apparatus let's say to make sure that this string is perfectly taut. Let me use this way. To make sure that this string is perfectly taut, before we even start the experiment, we're gonna set some load over here. Let's say we set 100-gram load over here, just to make sure that the string is taut. This 100-gram load would be out of our calculation. This is something that we call the dead load. This is the purpose of this dead load, is to make sure that the string is perfectly taut, so that we can take the initial reading. So we take this reading exactly on the meter rule. Then we are going to slowly start to add up force, add up load over here, and we're going to measure the new length. We're going to add loads over here, measure the new length. Add loads over here, measure the new length. So let's say you have attached your first 100-gram. So then you get a bit of extension. You record that. Difference of those two is your x1 or x100. Then you attach another 100-gram. The total mass over here is 200-gram. Dead load ta bad. So total weight is 200-gram. So you can essentially, from the 200-gram, you can convert that into kg, and then from the kg value, you can calculate the force, which is the weight of this 200-gram mass by W equals to mg, and then you can get your x200, then you can 300, 400, and something like that. Let's say we're gonna take, let's say 10 readings. So we are gonna increase 100-gram mass, and we're gonna increase the force up to 1,000 gram. So at 1,000 gram, this wire would be at its highest extended stage. And then you're going to slowly start to take the loads off. Now, interesting part or important part is that we will be taking one set of reading as we are going to load the wire. Loading the wire means we're going to increase the tension in the wire by attaching more load onto the hanging mass system. And also, when we'll be really removing those loads, let's say we're going to remove, let's say the maximum load we have applied is 1,000 Newton, 1,000 gram. Then we remove one piece. So now we have 900. You should take another reading, that what is the exact reading on the meter for that. Logic tells us this should be exactly same as the earlier, but for some experiment, it might not be exactly same because of some sources of systematic error or some bad reading. And whatever that reading is, you record it. So apart from the very highest reading, you should get two readings for all the in-between load values. One while you are increasing the load, and while you are decreasing the load, or we can say while you are loading the thing and you are unloading the wire. And to get proper graph, we should average those two numbers. For example, you get for extension of 900 gram, you get in loading case one value, and in during unloading you get a slightly different value. You average those two, and that value becomes your actual extension value for 900. So we essentially do that to increase the accuracy of the experiment and introduce repeated readings, which is a pretty important aspect for every experiment. So that's something that we can do to make sure that this apparatus setup works.
আর এই অ্যাপারেটাস যেটা আপনি দেখালেন এটা কি সিলেবাসে? এটা তো স্প্রিং না।
না, এটা সিলেবাসে নাই। আমি এই অ্যাপারেটাস সেটআপের কথা বললাম কারণ হচ্ছে এটা তো আমাদের P2 তে নাই, বাট এই রকম অ্যাপারেটাস সেটআপ বেস কোশ্চেন P4 এ আসতে পারে। ওই জন্য আমি এটা এত ইলাবোরেটলি আলাপ করলাম। যেমন এই ডিসকাশনটা আমি ক্লাস 9 এর বাচ্চাদের সাথে করি নাই বিকজ দে আর নট প্রিপেয়ার্ড টু টেক দিস, বাট whenever I'll teach them P4 I might discuss this with them. বুঝছো কি বলছে?
স্যার কিন্তু স্যার P4 এ তো আমাদের না যে স্প্রিং এর এক্সটেনশনটা এক্সপেরিমেন্ট করতে হয়। দিস ইজ দ্য সিম্পল কপার ওয়্যার।
That's the point that I'm trying to make. The elasticity is not an exclusive property of the spring itself. So elasticity is a property of any solid object. So whether we have a spring or we have a wire, they both represent elastic property. So the point I was trying to make that if we have a graph that is drawn for a piece of wire that is force versus extension, even if this graph is drawn for a piece of wire, force versus extension, then also we're going to call the gradient of this graph as spring constant. Even if this graph is drawn for a wire, we're not going to call this a wire constant. By default, the name of the gradient of force versus extension graph, the name itself is spring constant. বুঝছো?
So it is not necessarily the constant of a spring. It can be other elastic stuff as well.
Exactly.
Name it's spring constant. বুঝেছি।
Exactly. So we can say the spring constant of a wire is this, which can perfectly make sense, which means that we plotted a graph of force versus extension, and by mentioning the spring constant of a wire, we mean the gradient of that graph. That's what we mean.
Okay, sir. I once, one teacher once told me that the gradient of this force extension graph cannot be the spring constant because gradient means change, and over here we are taking the account of only one point.
And what is the other point of this graph?
There is no other point.
Yeah, there is another point. If you are trying to get a triangle, let's say you choose one point right over here. If you try
F1 by x1
and
equals to F2 by
what can be
x2
another
divided by
logical
F3
point?
by
It
x3.
could
It
be
can
here.
goes on for a lot of different values, all of which should be
Yeah, it could have a, it was my voice, my bad. So we can have a lot of different values, but to be honest, the one generic point that I can define is 0, 0, right?
Yes, sir.
For this straight line, because this line starts from the origin, obviously, because when no force is applied, essentially the extension of the object should be how much? 0. So because this graph goes to the origin, the gradient is the spring constant. If this graph did not go through the origin, then we might have some trouble, which I'm gonna show you after a while. If this graph did not go through the origin, then we might go through some trouble, which I'm going to show you after a while, when the x-axis will become the length axis. It might be that information that we're getting a bit confused with, but it will show up. So hold your horses. I'm going to discuss about that part of the graph after a while. Don't worry.
it takes a bit of a curve of decrease.
The part that I'm trying to discuss over here, let me get this whole graph. Okay. So the part that I'm trying to discuss is that whenever we are going to deform a certain spring or certain elastic material by applying load, this object is going to undergo elastic deformation or reversible deformation, which is represented by a straight line on the force extension graph. Beyond there exists a certain point of force beyond which this graph will no longer be a straight line. It will start to take a bit of a curve. This point where the straight line gets finished is called limit of proportionality. Limit of proportionality is a geometry-based point. It is not a point defined by the proper behavior of the object. The last point till which, or the last value of load till which the force extension graph is a straight line is the limit of proportionality of that specimen. Simple. The point from which it starts to get curved is where we say that it is now have started to undergo plastic behavior or permanent deformation behavior. So this region is called the elastic region, and this whole curved region is called the plastic region. However, this is not essentially the whole truth. The whole truth is within this part, we actually have 3 closely situated points. We have limit of proportionality, then we have elastic limit, and then we have another point that's called yield point. But you don't have to know about these things because these are not introduced in your syllabus. So one syllabus specifically বলে দিছে the concept of the elastic limit is not necessary for O-level kids to understand. So you just only have to know about one point, which is the limit of proportionality, and by definition, it is the point that is the end point of the linear part of the force extension graph. That's it. So if we apply a force bigger than the limit of proportionality, the curve starts to take a curve. The graph starts to take a curve, and eventually it will reach up a peak at certain point, and then from this point, this graph is gonna start to become losing its value. So there is a certain maximum value for up to which any specimen is able to take the force. Beyond this point, the object will undergo different type of deformation, and this cross line represents that breakdown. So why we have multiple different lines over here is not discussed in your syllabus. You don't have to know this. If you want, you can learn this as a single line. Just for better understanding, I actually give you multiple different lines. But this cross point represents that the object has now snapped into two pieces. So we are pulling, and eventually we broke the object at this position. আচ্ছা, এরপর ইন্টারেস্টিং পার্টটা হচ্ছে যে whenever আচ্ছা, এই যে এখানে একটা জিনিস দেখাচ্ছিলাম বললাম আমাদেরকে যে এই সিলেবাস দেখাচ্ছিলাম যে recognize the significance of the limit of proportionality for an elastic solid. An understanding of the elastic limit is not required. So elastic limit তোমাদের বুঝা লাগবে না. So you can forget about this factor. So what other things that I showed you? আচ্ছা, এখানে আমি মার্ক করতেছিলাম. Then I wrote that this orange part is the elastic region, and this whole blue part is what I call the plastic region. এই পার্টটুকুর ভিতরে f equals to kx applicable, and ওই পার্টটুকুর ভিতরে f equals to kx applicable না. So and then the same experiment I was showing by using a spring. So আচ্ছা, এখানে আরেকটা গ্রাফ যেটা দেখাচ্ছি সেটা ভালো করে খেয়াল করো before I came down. Have a look. In this case, we also have another apparatus setup. Let's say this is a spring and this is a hanging mechanism. This one's mass is considered negligible, or this is the dead mass. Dead load. Dead load means something that we will not going to take into consideration for our experimental mass value, which is required to keep a string taut, which is required to make a spring perfectly vertical, so on and so forth. It is a part of the apparatus setup, but not essentially a part of our measurement system. For example, if you have a spring, the weight of the spring is also a force that causes the spring to bend, elongate, right? For example, if you have a very long spring, for example, like a slinky, do you know what a slinky is?
Yes, sir. Coiled wire.
Yes, sir.
Did I ever show you that a slinky uncoils on itself if it is dropped?
Yes, sir.
Do you know that?
Yes, sir.
Sir, ওই যে নিচের এন্ডটা স্টেবল থাকে।
Yeah, if you drop a slinky from a pretty tall height, it's not going to touch the ground. It's going to first touch its bottom coil, then the whole thing is going to touch the ground.
Yes, sir, দেখেছি।
It's a very nice video. Hold on.
Something like this, we will always have.
এক minute. Okay. So কি বলতেছি? So I resume the recording. So let's say this is a apparatus setup for a spring. This is the original length of the spring L, and then we're going to add some load over here, and this is going to be a new length L prime, and then we can calculate the extension of the spring by L prime minus L. This is the basic setup. What if, other than plotting force versus extension, we decide to plot
The graph starting
length
goes with that. Let's say now have to have a look at the difference. This graph was F versus X, force versus extension. This graph is force versus length. The interesting part is that if we are trying to plot force versus length, whenever we have not applied any force whatsoever, it would still have some length, which means the length of the object can never be zero. At zero applied force onto the spring, the length was this much. So let's say the graph would start from this x-axis intercept, where this value is essentially capital L, the original length of the spring. Then as we're going to start apply load onto this hanger, so if we apply bigger and bigger force, then the graph is going to start from this point, and it's going to have the exact same characteristics as we have discussed earlier. So we're going to have a little bit of straight line part. So let's assume this is a straight line part. My hand drawing, so it's not very straight, but bear with me. So this is the limit of proportionality. I'm going to limit of proportionality. So in this case, this graph is not going to the origin, because this was not plotted for force versus extension. This was plotted for force versus length. So we have a bit of a dead space or intercept on the x-axis, because this part represents the original length, and from this part starts the change of length, or what we call that extension. So this is important, that whenever you are trying to answer questions, especially for the MCQ parts, that you be very careful to observe that what is the length x is represented as. Is it the extension, or is it the actual length of the spring? So these are the two variables that you really need to take care, so that you don't feel confused or miss out on the marks. বুঝছো কি বলছি?
জি স্যার।
Yes, sir.
এবারটুকু ক্লিয়ার? সো
না
যদি
স্যার,
আমাদের লেন্থ এক্সিস থাকে তাহলে আমাদের এটা কেয়ারফুলি দেখা লাগবে। বলো কিছু কোশ্চেন বলো আর হেল্প
স্যার বুঝি নাই স্যার।
বলো, কোন পার্টটা বুঝো নাই বলো।
স্যার আমি মানে আসলে কিছু বুঝি নাই স্যার, মানে ভিডিওতে কি বলতেছিলেন?
শুনছিলা?
শুনছিলাম কিন্তু বুঝতেছিলাম না স্যার।
Makes sense. So if we have force versus length, then the graph would not start from the 0, 0 point, because when no force is applied, the spring would still have some original length. The graph would start
আচ্ছা
from
স্যার বুঝছি।
non-axis intercept, and then the remaining graph would exactly have the same shape as the force extension graph. So this would not start from the 0, 0 point. That's the important bit, because we have to
জি
take
স্যার
care of
বুঝছি
this
এখন স্যার।
information for some MCQ questions, which we will be discussing after a while. যেখানে আমি কিছু MCQ আনছিলাম, এই যে for example, have a look at this MCQ that we are discussing in this question. Why is this not coming in full HD? It's supposed to be available in full HD. Much clear. I'm seeing it much clear. Do you guys also see it much clear? Suddenly,
Yes, sir.
and did the resolution suddenly become more clear?
Yes, sir.
Yes, sir.
আচ্ছা, তার মানে এখানকার স্ট্রিমিংটা হতেছে 1080p তে। This is very good. Zoom streams in full HD. Oh, this is amazing. Okay, have a look at question number 4. Just have a look at this. Try to solve this one. A spring balance is calibrated to give readings in newtons. The graph shows how the length of the spring varies with the load. A load causes the spring of the balance to extend by 3 cm. What is the balance reading? Try, read, attempt. Whatever you cannot do, I'll help you. But attempt first. দেখো এই কোশ্চেনটা সলভ করা যায় কিনা। Is it possible to zoom in? Yes.
স্যার কোন নাম্বারটা করতে বললেন?
15.
Number 4.
স্যার ডি হবে না 15?
Yeah, 15 is the correct response. Which one do you think is the most common wrong response?
স্যার 15 হবে।
স্যার 5?
5 is
5
5
স্যার 5.
5 is the most common wrong response. The correct response for this question is 15. সবাই বুঝছো কেন?
Yes, sir.
Because when the extension is supposed to be 3 cm, the total length is supposed to become 5 cm. And if you plot it on the from the y-axis to the x-axis, you get 15. So what you can see over here, what this graph essentially incorporates, that is different from my earlier graph that I showed, that here the load axis or the force axis on the horizontal axis and the length of the spring is on the vertical axis. So these two axes can be reverted back and forth as the teacher want them to show you. For example, you have a look over here. Here the load was shown for this question, question number 3. Load was given on the x-axis and extension was given the x-axis.
Sir.
So a second, we can also have these two variables flipped across. So load can be given on x or y or x, and extension can be given on the other axis. But important part is that the shape of the graph for force extension graph is like this, that you have a decreasing gradient after the limit of proportionality. So essentially, if you revert the axis, this graph is going to simply change its shape. So this is exactly why at this point in this question exactly. So at this question, you can see that whenever we have reverted the two axes, you see it goes up to straight up to a certain point, and then it starts to gain gradient because it is supposed to get slanted closer to the extension axis. That's why it is becoming more steeper. This is not a different object or different type of object. This is happening because we have now inverted the two quantities which are supposed to belong to x-axis and y-axis. Yes, someone
তাহলে ওইখানে ওই লিমিট অফ প্রপোর্শনালিটি দিলে কোনটা হবে? বি হবে না?
Limit of proportionality should be the point. Limit of proportionality is the point till which the line is a straight line. So this is on your screen. This is on
তো কার্ভ হয়ে যাচ্ছে না, বি তো হওয়ার কথা তাইলে।
বি তো হবে না স্যার?
এই কোশ্চেনের কারেক্ট রেসপন্স হচ্ছে বি।
স্যার ওই যে 4 নম্বরে তো বলছি এক্সটেন্ডেড বাই 3 সেন্টিমিটার, এটা যদি বলতো এক্সটেন্ডেড টু 3 সেন্টিমিটার তাহলে কি মানে 5 নিউটন হইতো না?
এক্স্যাক্টলি।
Thank you.
Sure. So what Shuri over here is highlighting is the use of a small preposition. He makes a very nice point. I really appreciate this thing. I didn't think of it, but yeah, it's a very good input. If this question was exactly same, except for this by was replaced by to. So if the question read like this, a load causes the spring of the balance to extend to 3 centimeter. What is the balance rating?
5.
Then it should have been 5, right?
Yes.
Because if the whole length is 3 centimeter, then it is 5. If it is extended by 3 centimeter, which means 3 centimeter more of 2, which is altogether 5, that gives you 15. So very important to go for the preposition. I mean, grammar can make a lot of, interesting stuffs. So this was the example that I took the kids in that to show them how this kind of questions can with force versus extension can show up. And then I think we can have a bit more discussion about other stuffs. For example, over here, what is happening here? Oh, then I showed you a simple problem for how we can work with force versus extension graph. And if equals to kx equation at a particular application, that how can we go for this? So if f equals to kx is a proportional, then k is a constant, which means the ratio for f versus x within the limit of proportionality. I mean, within this linear part of the force extension graph, these two variables should all be proportional for any value of f and corresponding value of x. So if we have those two things in ratio, you get a proportionality relationship like this, equation like this. And if you know all the three values, then the fourth value can be very easily calculated. So that is also a part of a way of our calculation. Eventually, they have another marks question এবারে আরো ইন্টারেস্টিং কোশ্চেন হিসেবে আসবে। So এখানে আমি স্টুডেন্টের সাথে কিছু কোশ্চেন সলভ করছিলাম, which are, do you have this MCQ paper with you?
Yes, sir.
Yes, sir. Yes, sir.
So do you have any specific question that you would like me to discuss? আচ্ছা, এখানে আমি একটা জিনিস আলাপ করতে চাই। This is very interesting part is that yeah, this is one of the parts that I'd like you to hear from the video, and then if you have further question, I'll discuss again, don't worry. If we plot on the for if easier or questions for this question, let me elaborate what it actually means, easier or harder to deform. A piece of copper wire as the load on it is increases. What does the graph show? At a certain load, the wire becomes easier to extend. A certain load, the wire becomes harder to extend. The load and extension are directly proportional formula, the inverse proportional formula. Okay.
So yeah, I think two.
C and D are actually essentially out of the question. Now let me elaborate. Yeah, A is the correct distance for this question. Let me elaborate what it actually means, easier or harder to deform. What does that term essentially mean? I'd like to elaborate this a little bit. What I want you to understand, if we plot the graph of multiple objects for force extension scenarios, let's say if we plot on the same graph the force extension for two different metal wire, let's say one metal wire has a force extension graph that look like this. I'm just drawing the linear part. I'm not going for the other part. And another wire on the same scale uses a force extension graph for the linear part that looks, let's say, something like this. Between these two wires, which one is easier to deform? Now, what does that term mean? Easier to deform. Easier to deform means that to achieve equal amount of deformation, you'd have to apply less force. Or in other terms, if we apply equal force to both of them, one will extend more, the other one will extend less. The one that will extend more is easier to deform. So between these two wires, brown and red, which one do you think is easier to deform?
Red. Red.
Essentially, the red is easier to deform, because if you want to achieve the same amount of deformation, let's say if I assume to draw a small thin line for a random extension, let's say if I want to achieve this much extension, for the red we'd have to apply a pretty small amount of force, only this much. But for the brown, we have to apply a very large amount of force, which means between these two wires, the one that has a lower gradient on the force extension graph is easier to deform. So that's the idea. Whenever this graph starts to lose gradient, so which means steeper graph means harder to deform, and slanted graph means
easier to deform. If I now consider the actual graph for a single piece of wire, what we have seen that for a starting behavior, we have a linear behavior, and then the graph slowly loses gradient. Whenever the graph loses gradient, it essentially means that it becomes easier to deform, because then to achieve the same amount of deformation, you would have to require that you would not require to increase the force by the same proportion. You can reduce the force by increase the force by a smaller amount. Let me tell you, elaborate mathematically what I mean. Let's say if this is the limit of proportionality, let's assume this is the limit of proportionality. Up to the limit of proportionality, the amount of extension is this much. So if you want to extend the object from its natural state to this point of extension, you have to apply this much force. Okay, works. But if you want to achieve beyond the limit of proportionality the exactly same amount of deformation, let's say if I want to double this line, would you have to apply the double amount of force? Let's try this out. If I just go above onto the graph and extrapolate this point onto the force axis, you will find out that the required force is simply not double. To achieve this much extension, you have to apply this much force. To achieve additional equal amount of extension, you only have to apply this much force. So you did not have to apply same amount of force, rather you have to apply a less amount of force, which means deforming the object actually became easier. বুঝা গেছে কি বলছি?
Yes, sir.
Did it make sense all through? So
Yes, sir.
এখানে ইম্পর্টেন্ট পার্টটা হচ্ছে আমাদেরকে এক্সিস গুলো খেয়াল রাখতে হবে, যে ফোর্স এক্সটেনশন গ্রাফ যদি হয় তাহলে গ্রেডিয়েন্ট লস মানে হচ্ছে ইটস বিকামিং ইজিয়ার টু ডিফর্ম। বাট যদি এক্সিস উল্টায় দেয় তখন কিন্তু আমাদেরকে আবার রিভার্স ভাবে চিন্তা করতে হবে, যেটা আমাদের অ্যাকচুয়াল কোশ্চেনে ছিল, যেটা একটু আমি আলাপ করব। দেখো সি ফার্দার।
Yes, sir.
Okay, so this is why A is the correct response for this question. Beautiful. Number 9. So this এই যে এখানে জিনিসটা বলছিলাম যে হ্যাঁ বলতেছি স্যার, if you have a look at this question, in this question extension was on the y-axis and load was on the x-axis. So typically what I discussed was force versus extension or load versus extension. So in the load extension graph, the losing gradient represents easier to deform. But whenever I'm gonna revert the whole the two variables, x goes on the y-axis, y goes on the x-axis, then the graph is also gonna change its shape. So then the graph is gonna be straight line, and then it's gonna start to become more steeper, or it's gonna get closer to the x-axis, extension axis. So in that case, increasing gradient would represent easier to become deformed. So that's essentially what happened in this MCQ. If you have a look over here, the graph shows the extension of a piece of copper wire as the load on it is increased. This is a piece of wire, and we are still plotting load versus extension graph. What does the graph show? At a certain load, the wire becomes easier to extend. At a certain load, the wire becomes harder to extend. Because this is extension, this is load, and it shows you what? That the graph is actually increasing in gradient for the extension load graph, which means if you think for the regular sense of load extension graph, it would be actually losing gradient, which means up to this point, the wire is really difficult to deform. Beyond this point, the extension becomes easily, because you would not require to increase the force as much or increase the load as much as over here to get the same amount of deformation from this figure. বুঝে গেছে? সো যদি আমাদের এক্সিস গুলো উল্টায় দেয় তখন কিন্তু আমাদেরকে একটু ডিফারেন্টলি চিন্তা করতে হবে। The information is very simple. You just have to be careful what is provided and what you are judging. You just have to be careful. That's all that is required. Do I make sense?
Only A answer.
হ্যাঁ, এই কোশ্চেনের কারেক্ট আনসার এ। Yes, definitely.
Sir, 70
7 দেখো, have a look. I'll help you. If you have questions, I'll definitely help you. But give it a try first. I'll help you. Don't worry.
স্যার আছেন?
মানে কি আমি কি করছি? আমি তো কিছু করি নাই।
You're not in the meeting হঠাৎ করে।
আচ্ছা, আমার নেট মনে হয় একটু লাভ দিচ্ছে, জাম্প করছে। আচ্ছা, এনিওয়ে, I've come back. Is the recording? The recording is on. দেখতেছো সবাই আবার?
Yes, sir.
হ্যাঁ, তাহলে কোশ্চেন নাম্বার
Sir,
7 কারেক্ট রেসপন্স কি হবে? What do you think is
D.
In my opinion, D is the obvious correct answer. But if you are confused about any of the other one, you tell me about this, then I'll tell you why that is not the correct response. But if you're dead set that D is the correct answer and I know why, we can move on. Anyone? Confusion? No. So
why a
Sir,
yes.
স্যার আমি বুঝছি না যে একটা কপার ওয়্যার কিভাবে স্টেজ করতে পারে, এটা সলিড জিনিস না।
Yeah.
স্টেজ করবে না।
Ductile. বলতেছি. There is a range of stiffness for solid and liquid objects. A rubber is also a solid object. Does it not stretch? An elastic rubber band is also a solid object. Does it not stretch?
Yes.
It does. Then let me give you another extreme idea of liquid. A toothpaste is a liquid. Now, can you accept that?
Sir, extreme dense liquid.
Type. জি স্যার, লিকুইড।
A toothpaste is by definition and characteristics a liquid. It's a very viscous liquid, but it is a liquid. So if you go a bit low on the side, I mean, there may be body lotions, and then there may be honey, then there is oil, and then there is water on the lower side. That's more liquid, like that, the way we understand or perceive liquid. So yeah, pretty much like a rubber specimen can extend, a metal wire will undergo extension as well if you pull it strong enough. But that extension would be pretty difficult to achieve depending upon how thick of a wire are you working with. If you are working with a pretty thin wire, it will deform pretty easily. If you work with a really thick wire, it will be deforming really small, but it will deform.
স্যার বলতে স্যার আমরা একটা থিন ওয়্যারকে পুল করলে তো স্যার ওটা লাইক ব্রেক করবে স্যার, অনেক ইজিলি স্মল ফোর্সে।
Yes. The
আমরা অবজার্ভ কেমনে করব চেঞ্জ?
we'll have
যে
to
এক্সটেন্ড হইছে।
we'll have to increment the force by small increments. Other than using 100 grams, we might as well increase the mass by 50 grams maybe. We might be increasing the mass by 10 grams maybe, or 25 grams. So we'll have to make that step increase smaller so that we can actually keep our experiment within the limit of proportionality. That's the idea.
So আমরা এখন অবজারভেবল চেঞ্জ পাবো?
Definitely. Observable change অবশ্যই, and observable change পাবো কিনা সেটার একটা predominant factor হচ্ছে that how much long of a wire are you experimenting with. If you start your wire to be pretty small, then your proportional length would be also very small. But if your initial length of the wire is significantly long, then you will get proportionally long length within the limit of proportionality. So if you want to have observable or measurable length variation with a meter rule, which is the millimeter scale, is your millimeter is your smallest fraction, we should consider having a long enough wire to start with. That makes a world of difference.
ওকে স্যার, বুঝছি।
বুঝা গেছে?
জি স্যার।
আচ্ছা, বিউটিফুল। আমি এটা পিডিএফ মনে করে বারবার খালি মাউসের স্ক্রল বাটন ঘুরাই দিচ্ছি। আচ্ছা, এই এক্সপ্লেনেশনটা দেখো, এই কোশ্চেনের এক্সপ্লেনেশনটা দেখো। This is actually a nice explanation.
Okay, that's also pretty. Shows the limit of proportional for this solid limit of proportionality. Okay, I would like to ask you, tell you one more thing. The length of this graph represents the elastic region. For example, O is the origin, OP is the elastic region, P is the limit of proportionality. Limit of proportionality is the name of a point. It is not the name of a length of variation. Did you get my point? I say it again. Limit of proportionality is a point on the curve, not a segment of the wire of the curve. Straight line segment is called the elastic region. Curved segment is called the plastic region. P is called the limit of proportionality, and then PQ is the plastic region, or you can say permanent deformation region. So plastic region. So limit of proportionality is a point of the graph. So that's why the characteristics for this is P, not OP. Sometimes students mess up and give OP. OP is called the elastic region, and PQ is called the plastic region. P is the distinguishing point between them, which is the limit of proportionality, borderline. Question number 11 happens to be the most interesting MCQ of this entire paper. I'd give you some time. MCQ টা try করো সবাই.
Sir, unit কি চেঞ্জ করতে হয়?
Let me not give you any hint right out of the bat. আচ্ছা এটা তো ভিডিও কোশ্চেন ছিল. কি করবা তোমাদের ব্যাপার, but this is the most unique MCQ of this whole MCQ compilation that I have in this thing. So give it a try. Number 11, try করো. এই ক্লাসটা বুঝা যাচ্ছে না পোলাবান?
জি স্যার।
তোমরা তো দেখছো সবাই যে এটা কোত্থেকে অ্যাক্সেস করছি, দেখছো না?
ইউটিউব।
হ্যাঁ, ইউটিউবে ক্লাস 9 এর প্লেলিস্টে আছে। So if you want some reference from here, you can always go back here, take a good peek at this picture. তোমাদের আজকে লেকচার আমি আপ করব, তোমরা চাইলে তোমাদের লেকচারটা দেখতে পারো if you want, but whatever helps. বলো
অ্যানসার সি স্যার।
এটা কারেক্ট আনসার হচ্ছে সি। I'll give more time to everyone because just because someone could get the correct answer doesn't mean that the attempting duration is over. Attempt more. I'll give you more time to solve this question. আমি প্রিন্টারে কাগজ ভরতে ভরতে আর প্রিন্টারে ট্রাবল শুট করতে করতে বুড়া হয়ে গেছি। Well, it goes without saying, what goes around comes around. Because I was absent for a month, more than a month, I have to take this extra burden.
চুল পাকছে?
চুল তো পাকছে বহুত আগে, মানে the first hair প্রথম চুল পাকছে বহুত আগে। রিসেন্টলি আমার একটা বড় দাড়ি পাকছে এবং দুইটা গোফ পাকছে।
স্যার আনসার কি ডি হবে?
All right, I'll go for the solution right now. I'll show you the solution from this video and have a look what is happening. I'll give you some time.
No.
To see the what thing is provided.
Yes, sir.
If the original spring of the length was already provided, had it been already provided, then this would have been much too easier, but it is not provided. So a few things that we can essentially take care is that we can try to build up the information that we have over here. So I'm going to take up this quotient and bring it up over here. Let's see if we can do something. Okay, that's about enough space. So it says 100 gram mass is suspended from the spring next to a vertical meter rule. The top of the spring is level with that 0 centimeter mark. The bottom of the spring is level with 27.2 centimeter mark. The 100 gram mass is replaced with a 600 gram mass. The length of the spring is now 89.7. The spring has not reached the limit of proportionality. The 600 gram mass is now replaced with 200 gram mass. What is the length of the spring? So let's try to do stuff. For example, let's assume that for 100 gram mass right over here. Let's assume that extension is supposed to be x. So this entire length, 27.2 centimeter, has the original length of the spring plus the extension for 100 gram mass as well. So I'm going to write this up over here. This is just one way to solve the problem. There are multiple different ways. I'm just showing you one of the ways that is easier to understand. But it's a bit elaborate, but it's easier to understand. So let's assume that for 100 gram mass of load, we have an extension of x. So I can write, following the formula F equals to kx, I can write that 100 gram, so let's say 100 into g, this is the gravitational acceleration, g, mg, equals to k into L plus x. See if it makes sense. Did I just write it wrong? I might. No,
supposed to be there.
I don't actually have to have this equation. Sorry. This is all right. I could write this, but I don't need this. What I can write, actually, I was thinking the other way around.
Use the f by x equals to f1 by x1 thing. So
this is the first equation that I am writing, that L plus x equals 27.2. Next thing it says, the 100 gram mass is now replaced with the 600 gram mass. Now try to think about it. If you have for 100 gram mass, if we assume the extension to be x, what would be the extension for 600 gram? 6x. Check this out. এটা কি ঠিক আছে? এই লজিকটাকে বুঝতেছো?
জি স্যার।
So I can write over here L plus 6x is supposed to be what? 89.7. এই দুটো ইকুয়েশনকে সাইমালটেনিয়াসলি সলভ করলে আমরা L ও পাবো X ও পাবো না? এই দুটো একটু সলভ করে দেখো কত হতো।
Simultaneous.
Yeah, you can just subtract to get the value of x, and then solve this to find out the value of L and X.
So I didn't understand the second equation.
Oh, the second equation says that the 100 gram mass is replaced with a 600 gram mass. So whenever we're going to replace this thing with a 600 gram mass, the spring is going to be farther long, and then the bottom of the spring or the length of the spring will become this much. So this much is the total length of the spring under the effect of a 600 gram mass. Within that length, we have the original length and also the extension due to the load. So how much is that extension supposed to be? That extension is happening under the effect of a 600 gram mass. Because we know that what? F equals to kx, so force directly proportional to extension, I assume that for a 100 gram mass, the extension was x. So logically, 600 gram of mass should give you 6x deformation. Because they are proportional to each other, force and deformation are proportional to each other. So if you we increase the force by 6-fold, so the extension should also be 6-fold. So this new total length should be the sum of the original length plus 6 times the deformation for what deformation we had for the 100 gram mass. That's the second equation.
So doing this gives 5x equals to 62.5, which means x equals to 12.5. Now we add that 12.5 to 27.2 and get C 39.7.
Yep. So x equals to 12.5 centimeters. So what does that make the L? L would be, I think, if we do the subtraction.
89.7 minus 27.2. So 62.5.
না এল এর ভ্যালু আরো ছোট হবে। এল কত হয়?
Oh, let me check.
27.2 minus 12.5.
16.7.
14.9. No, 14.7.
14.7.
40.7 na?
Yes, sir.
Yes, sir.
14.7.
40.7 centimeters. So once you have these two values, finding out the next part of the question is pretty simple, because it says that now the 600 gram mass is replaced with the 200 gram mass. So what is the length of the spring? So what we are trying to find out is L plus 2x equals to what? If you have the value of L and X, you can very easily find this out. What Amin Hamza just proposed, that other than finding out the value of the L, we don't have to find this out. Actually, we don't. Once you find out the value of X, you can very easily add the X with this one, because we already had the value of L plus X. We want to find out what is L plus 2X. So essentially, what do we have to do? We have to add with L plus X another X. ঠিক না? Think about it. আমাদের অলরেডি L plus X এর ভ্যালু অলরেডি আমাদের জানা আছে, সেটা কত? 27.2. সো আমরা যদি X এর ভ্যালুটা অলরেডি বের করে ফেলি, আমরা তার সাথে আরেকটা X অ্যাড করে দিলাম, 12.5 যদি এটার সাথে অ্যাড করে দিলে আমাদের L plus 2X বের হয়ে যাবে। That should essentially be your answer. So ওটা তুমি করতে পারো। You can skip the finding out the value of L if you don't want to. If you can take that jump, or you can directly do it in the exact mathematical way. Make up this two equation, solve this equation, then find out L plus 2X in a very traditional way, which also perfectly works. Whatever you can capture easily, you can remember it more easily. Whatever that makes your brain accept far to more retaining way, that's what you adopt. Perfectly all right. বুঝা গেছে কি এই কোশ্চেনটা কেন ইউনিক? বুঝা গেছে কি কোশ্চেনটা কেন ইউনিক?
Yes, sir.
Original লিঙ্কটা দেওয়া ছিল না। That's what required for us to make the equations and slowly make our way through. Whenever I first solved this question, it took me a pretty long time to even take a bite in this question. I was a bit perplexed that how to solve this question. I did not actually think that for an O-level MCQ, it would require this many steps. But what I later came to understand, that there is practically no other alternative way other than what I just showed you, that making the equations and such to solve this question. I don't know a much easier way.
Sir.
There isn't much easier.
স্যার L plus 2x টা বুঝি নাই।
Sir, 600 minus 100 করে, then divided by deduction of their length equals to 200 by x করলে কেমনে জানি অ্যানসার এসে পড়ে, বাট কেন
আচ্ছা
আসে
স্যার,
এটা
ইউনিটারি
বুঝতেছি না।
মেথড করলে হয় না স্যার?
অ্যানসারটা মিলে, বাট কেন মিলতেছে এটা বুঝি নাই।
আচ্ছা বলতেছি,
Original length cancel হয়েছে তাই।
if you have a method of making the answer correct, but you don't understand the underlying principle, I highly recommend not to adopt this as a actual result for your answering, because this would not help you learn something. বলতেছি, one of you just asked me that লাস্টের স্টেপটা বুঝো না, L plus 2x টা বুঝো না। খেয়াল করো, আমার এখানে লাস্টে কি করতেছি, the 600 gram mass is replaced with 200 gram mass. তো 100 গ্রামের জন্য এক্সটেনশন অ্যাজিউম করেছিলাম x, তাহলে 200 গ্রামের জন্য এক্সটেনশন কত হবে? L plus 2x হবে। মানে 200 গ্রামের জন্য এক্সটেনশনটা হবে হচ্ছে 2x, তার মানে টোটাল লেংথ অফ দ্য স্প্রিং হবে L plus 2x. So this is our unknown. This is what the question is asking us to find out. তো আমি যদি L আর x এর ভ্যালু জানি, L plus 2x বের করা খুবই সিম্পল, which is this much. This was one way to go for by simultaneous solution and directly calculate L plus 2x. 2x কেন? Because now we are trying to find out the extension plus original length for a 200 gram mass. Alternately যেটা হচ্ছে সেটা হচ্ছে, we already knew L plus x, and we have just calculated the value of x. So to find out L plus 2x, why don't we just add the x value with the L plus x value, which means our L plus x value was 27.2, and we want to calculate L plus 2x. So simply add the one additional x to 27.2. So if you add 27.2 plus 12.5, you still end up with the same answer. বুঝছো? কে যেন 200 L plus 2x এর পার্টে কোশ্চেন করছিল, বুঝছো?
Yes sir, yes sir.
স্যার 2x না ইউজ করলেও হতো না স্যার? মানে
propose me a way by which you plan to solve this other than this. I'm all ears.
স্যার ওই যে কনস্ট্যান্ট
x equals
কনস্ট্যান্টটা
to
ধরে
27.2, এই ইকুয়েশনে যদি আমি x এর ভ্যালুটা বসিয়ে তারপর সলভ করতাম তাহলে আসতো না স্যার? সি সি তো পেয়েছি আমি স্যার।
কনস্ট্যান্টটা তো দুইটার জন্যই কমন, ওইটা ভ্যারিয়েবল ধরলেও তো করা যেত।
কোনটা কনস্ট্যান্ট?
স্যার ওই যে f equals to kx ফর্মুলাটা, কনস্ট্যান্টটাকে যদি আমরা সাবজেক্ট করতাম তাহলে তো দুইটার জন্যই কমন হয়ে যেত না। আর এই ইয়াতে বেসিক লেন্থ যেটা ওইটা x ধরে নিতাম।
Or cancel হয়ে যাবে।
So you didn't get me?
Sir, if we take the original length to be like 27.2, then 600 minus 100 is 500, right?
That's the problem. That's the problem. Should you take original length to be 27.2? You should know.
Sir,
Like I think the examiner is meant to like when you apply 100 grams force, that's when the string becomes taut. Like if it's not applied to a force, it's not its original, like something like that.
No, it doesn't say that.
Sir, K subject করলেও তো করা যায়
If the 100 gram mass is suspended from a spring next to a vertical roll, the top of the spring is level at 0.0 centimeter mark, the bottom of the roll is 27 centimeter mark. All that this paragraph implies is that the total length of the spring, extended length of the spring, is 27.2 centimeter mark under the effect of a 100 gram load. That's all pretty much it proposes. So, আচ্ছা আমি তোমাদের একটা করে আইডিয়া আমি অ্যাপ্রিশিয়েট করতে, so give me some time. I'm willing to look for all of your proposed solutions. So one of you just proposed me that what if we do this? Force equals to k টাকে আমরা কনস্ট্যান্ট ধরলাম kx. So আমরা এই ইকুয়েশন দিয়ে যদি কাজ করতে চাই, so first case আমাদের ছিল হচ্ছে 100 gram. So let's say 0.1 kg into g is the force, k is a constant, and in the first case the extension should be how much? Let's say the length of the
27 minus L.
Let's not use x. I would like to use L because it makes my understanding a bit easier, because x is the general symbol for extension, so might not as well mingle with that. So let's say I'm going to write 27.2 minus L. This actually works. Okay? For the next figure, I can write that 0.6 into g equals to k into কত 89.7 minus L. এটা না বলতেছো, প্রপোজ করতেছো?
Yes sir, এখন ওই দুইটা ইকুয়ালস করে দিব।
এখন এই দুটোকে ডিভাইড করে দিব।
জি স্যার।
Yeah, so if I divide these two equations, what I'm gonna get is 1/6 equals to 27.2 minus L divided by 89.7 minus L. এখান থেকে হিসাব করে আলটিমেটলি আমার L বের হবে। Obviously এই L টা আলটিমেটলি ওই যেটা ক্যালকুলেট করছি ওইটাই বের হবে। ক্যালকুলেট করে কত পাইছিলাম এখানে জানো? 14.7। সো এখান থেকে L এর ভ্যালু 14.7 বের হলো। আচ্ছা, এইটুকু তুমি বের করলা অরিজিনাল লেন্থ। এখন তোমাকে বাই করতে হবে হচ্ছে 200 গ্রাম, the total L prime due to 200 gram mass কত হয়, এটা এখন তুমি কিভাবে বের করবা? Go forward, propose me further. How do you get to that? You did not calculate K by the way.
হ্যাঁ, এখন ওই যে ওই ইয়াটা রেশিও ফর্মুলাটা ইউজ করব।
বলো কি লিখবো?
ওই যে 100 divided by 12.5, that is 27.2 minus, wait.
So 0.1 divided by G divided by 0.2 divided by G. This one?
No. So can you just show me the math again, like the question?
Sure.
Yes, sir. You're going back.
Okay. So 0.1 divided by G divided by 0.2 divided by G equals to, we're gonna write K into 27.2 minus 14.7, which is possible, and then we're gonna write K into unknown, which we are trying to find out. Let's say this is L prime minus 14.7. এই তো মানে সেম স্ট্রাকচার।
Yes sir.
সো এখান থেকে হিসাব করলে আলটিমেটলি আমার L প্রাইমটা বের হবে। এখান থেকে ডিরেক্টলি আমার L প্রাইম 39.7 বের হয়ে যাবে। Yeah, that's also perfectly logically acceptable. But once again, you are doing two set of equational approach, and practically what I did over here is also a two set of equational.
এই মেথডে কি এরর হওয়ার চান্স আরো বেশি হয়?
স্যার আমারটা
হ্যাঁ বলছি তো, আমি সবার আইডিয়াই নিব। It's not about the chances of error. The procedure that you followed over here is perfectly all right. It makes sense. It is consistent to what you have learned. It perfectly figures out the formula. We have used reference to kx with appropriate ratios. It's good, and it will work out fine.
Sir,
but জিনিসটা হচ্ছে যে the probability for you to mess up in the first place, if you're not thinking properly, many students might actually write over here 27.2 only. So if they don't carefully write 27.2 minus the original length, then this whole procedure would be wrong. Writing this first sentence properly will lead to the whole thing coming out correct. I mean, this part inside the bracket, you are supposed to write the extension, not the whole length or not the original length, the extension. This is the part that you have to be careful about. Well, carefulness is the key always, but this is a perfectly valid way to go for the math. You can also do this if this one feels comfortable in your head. No big
So
deal.
স্যার আপনার যে ওই যে 0.1 into g পরে 0.2 into g এটা স্যার না করলেও তো হয় না কারণ ইয়া তো ক্যান্সেল আউট হয়ে যাচ্ছে ইভেন্চুয়ালি
Well, the reason I am using the g values is to show you that we are actually working with force, but g essentially gets cancelled out. But to make valid calculation formula, I use the gravitational acceleration g. But it actually cancels out. You can choose not to write this in your head. You know that it's getting cancelled out. But I'm just showing the g over here so that now none of us get confused that how are we getting mass equals to kx. No, we're not getting mass equals to kx. We're getting force equals to kx. বুঝছো?
Yes sir, yes sir.
আচ্ছা, ইউসুফ একটা জিনিস প্রপোজ করছিল যে
Sir.
what if we go for a unitary method? Can we go for direct unitary method? We cannot go for a direct unitary method. The reason we cannot go for a direct unitary method because if you think about it, this question is giving us force versus length information. So you have the information available for 100 gram load. So let's say 0.1 into g, 0.1 g. You have that much length available. That according to the question, this length was 27.2. Then you have the information available for 0.6 into g. So that information was given to you as 89.7. So that length was, let's say over here, 89.7. And you are asked to calculate what would be the length for 0.2 g. So you are asked to calculate a value somewhere over here. If you think about this force versus length information, this graph is not going to pass through the origin. If it does not pass through the origin, your equation is no longer a y equals to mx. So your equation is y equals to mx plus c. Unitary method only works for equations which are y equals to mx.
So
only
we can use.
for
So we can.
proportionality, you can use y equals to mx, unitary method. But for this method, unitary method will not work because you will not be taking care of this offset part. একজন করে ইউসুফ তোমার প্রবলেম, তোমার কোশ্চেন আনসার পাইছো কিনা যে কেন আমি unitary method ইউজ করতে পারবো না?
Yes.
বিউটিফুল। তাকিয়ে আসে, তুমি কি যেন বলতেছিলা?
স্যার আমি হলো যে স্প্রিং কনস্ট্যান্ট স্যার কে এর ভ্যালু বের করে করেছিলাম স্যার, ডিফারেন্সেস কম্পেয়ার করেছি স্যার, আমি মেসেঞ্জারে ছবি পাঠিয়েছি।
Beautiful, that actually helps a lot. We can look that up. Oh, okay, I know what to do. Don't worry, I know what to do. I have to keep it here, select it total, and then do the rotation. একই বিপদ। Hundreds. So let's see what Takiya is proposing. So what he is proposing is that 60 minus 10. So you
Newton.
are doing it for the Newton, okay? 0.6, okay, hand 60 Newton minus 10 Newton equals to k into x2 minus x1. Okay, you're practically subtracting two equations. Are you?
মানে স্যার আগেটা যেভাবে করছি ওভাবে সেমই নিচে করছি স্যার, মানে 20 গ্রামের লেন্থের জন্য। মানে স্যার আমি এক্সটেনশনটা বের করিনি স্যার, আমি ডিরেক্টলি 20 গ্রামের লেন্থটা বের করেছিলাম।
I can see that, but I'm trying to think about how this
Sir, 60 টা কি?
60 Newton.
Yes,
For 600 gram, you get 0.6 into 10, 0.6 kg into 10. You get 6 Newton, not 60 Newton.
So 600 গ্রাম 0.6 ইনটু,
আচ্ছা 600 গ্রাম তো 0.6 kg।
সবগুলো তো সেম ভুল করছি, শোনা হয়ে গেছে।
That makes sense, but not appreciated, but makes sense.
But sir, হয়েছে কিভাবে স্যার?
বলতেছি দাঁড়াও, I have to think. This is reverse engineering, looking at the solution and try to figuring out the way, so it takes time. Okay.
আচ্ছা স্যার, এই রিভার্স ইঞ্জিনিয়ারিং আসলে ইঞ্জিনিয়ারিং কোর্সে শিখায় স্যার?
Reverse engineering typically কেউ কাউকে শেখায় না. Reverse engineering is something people learn by researching.
ওকে স্যার।
Well, this is what Takayase did without knowing what he did, maybe, or maybe he knew what he did, because I don't know. So the current version of this math is going to look like this: 6 Newton equals to K into 89.7 minus L. Then it's going to be 1 equals to K into 27.2 minus L. He subtracted these two equations other than dividing it, because in the proposed solution from Shurid, we come on, I cannot move this. Okay. In the proposed solution from the Shurid, we actually did this thing, and then we divided this equation. What Takayose did, he subtracted these two equations. So what is he gonna get? 5 equals to K into this L and L will cancel out each other naturally. So we are gonna get A is 9.7 minus 27.2, which ultimately should give us K equals to 4 divided by 50. Now, এটা তো হচ্ছে এটা কত হয়? এটা হয় হচ্ছে কত? হেল্প করো তো আমাকে একটু এটা সলভ করতে। 5 ইকুয়ালস টু, এটা ব্র্যাকেটে কত আসে দেখো তো? 89.7 minus 27.2, এটা করলে আসলে 62.5, ঠিক আছে? তো K ইকুয়ালস হবে হচ্ছে 5 divided by 62.5. এটাকে ফ্র্যাকশনে নিলে কত হয়? 5 × 65, 5 × 60, 12.5. দেখো 12.5 হয় কিনা K এর ভ্যালু?
স্যার 0.08 এর কথা না,
1/12.5 হয় কিনা? আচ্ছা যাও, এটা ভ্যালু কত হয়? ক্যালকুলেটর এটা ভ্যালু কত?
স্যার 2/25 or 0.08.
আচ্ছা 0.08 লিখি, 0.08. So this is supposed to be his K value. Then he did the exact same thing but using the equation for 200 grams. So what he did is that he is writing the equation for 200 grams. This is supposed to be 2 Newton equals to K into his length that he does not know. Let's name this L prime, which he labeled over here as L, because he is only using one variable, jumping through the equations, and minus the original length that we don't know. So this is his final equation, and now he's going to subtract. Let's say this is equation number 1. Let's say this is equation number 2. Here we did 1 minus 2, and now in this step we're going to do 1 minus 3. This is 3, let's say. So if we do 1 minus 3, we're going to get 6 minus 2 equals to K into 89.7 minus L prime. So he knows the value of K, replaces it, and it ultimately gets the value of L prime. Yeah, this perfectly works. The reason it works, because in all of these things, the original length was embedded. So because he was doing subtraction, those constants, for example, the constant of y equals to mx plus c, that c constant got subtracted from both sides. So he didn't have to bother about this. Although this looks like a direct proportionality of y equals to mx, but it's not. It's actually y1 minus y2 minus y1 equals to m into x2 minus x1, because both the constant c and c got crossed out. That's why this math worked out. বুঝা গেছে?
ওকে স্যার।
আচ্ছা, অভিক কিছু একটা বলতেছিলাম মাঝখানে। Could you please?
Sir, so we can use unitary method for the part where we, like, from 100 Newton to 600 Newton.
Is for the difference you can use unitary method, but for the absolute values you cannot. I mean, you
Sir,
can.
if we
Bolo.
Sir, if we use the unitary method and find the like extension for 100 Newton, we can add that to the extension we already had 400 Newton, then it would be the extension for 200 Newton. That's how I got the answer.
Yeah, that's perfectly all right, because you are trying to find it out for the difference of the extensions. You are not going for the absolute value given. So what we are proposing is that we can find out that for a difference of 500 gram, the difference of total length, which is that actual extension, was supposed to be 62.5. মানে 500 গ্রাম of mass, 500 গ্রাম massের জন্য আমাদের লোড যা হয় আর কি। So a total of 500 gram mass gave you a total extension of 62.5. Then you calculated what should be the extension for 100 gram. You are calculating the extension for 100 gram. This is 62.5 is the subtraction of 89.7 minus 27.2. So this is the actual value of the total extension caused by an additional 500 gram. I'm using the word additional to make sense. This length increase is completely extension that was caused by the addition of 500 gram mass. So 100 gram replaced with 600 gram means basically that you increase the load by 500 gram. So how much should the additional extension be if we attach only 100 gram mass? This gives you 1/5 of that. So 1/5 of 62.5, which gives you 12.5. So this is the amount of extension that you're gonna get for only 100 gram mass of additional extension. So what Ovik is proposing, because we already know that L plus 1, we already know that for 100 gram load, the total L plus X equals to 27.2. So why not for 200 gram, we go for L plus X, which is basically 27.2 plus 12.5. So which gives you koto? 12.5, which gives you 39.7. This is also perfectly all right, as long as you can make sense that this is the unitary method done using exclusively extensions, not the full length. Did you understand what happened here? Polaban?
Barely sounding, sir.
This is M2 minus M1. This is the X2 minus X1. So that you could find out an increase of 100 gram makes an additional extension of 12.5. So every addition of 100 gram increases the length by 12.5. That's what this math means. Every additional
So it's
100
basically
gram,
the simultaneous equation, but we are writing it in a different way.
practically yes. Well, ultimately if you think there are different ways to problem solve it, I'm sure there are different ways to solve this problem. All of these things which pop in your head, which we propose, the things that I've written over here, they are perfectly valid methods because they hold up the equation true and don't mess up the variables. Each of these methods are equally acceptable. If these things that can make sense of you make sense to you, you can choose any of these things as your going methodology. I personally like the one that I showed, because the amount of mathematical complexity, in my opinion, is small to work with. That's just my proposition, but you don't have to take my word for granted. For those who could do it in a much easier calculation process, do it. No big deal. Be my guest. বুঝে গেছে up so far? Pawan? Any question? To add with L plus X another X, ঠিক না? Tell you. If we add two of these springs in series, the last thing that we have is that what's going to happen for two type of combination, for series and parallel combinations. So we're going to see about this part over here. And at the bottom of another spring, let's long would this whole combination become? Would it still extend by X, or would it extend by more than X or less than X? What do you think?
More.
There was one response. One of the person said more. There are 19 left.
Or less.
Can you repeat the question?
If we add two of these springs in series, one after another, and apply the same amount of load W as it was done in this case, what would be the total extension of this whole combination? Total extension of the whole combination. Would it be more than X, equal to X, or less than X?
More
Equal
than
to
x.
x.
Equal to x.
Equal.
Equal to.
Equal to.
Okay. Let me help you to understand.
Equal to x.
Okay, yeah, I really appreciate the responses, but let me explain. This thing is perfectly stable, right? This thing is perfectly stable. If we apply W load over here, this load would work on all the sections of the object. Let me elaborate what I mean. Think about it. If you have a piece of string, let's say you have a piece of string. If you apply a 1 kg load over here, you would have a 1 kg weight of tension on every single point of the string, right? The entire rope would be taut. ঠিক না? It's not going to be that in some places the rope has half kg weight of or the force. In other places it has more than 1 kg. The entire string would have the same 1 kg. I mean 1 kg means what? 10 Newton. 10 Newton of force along its entire length. Is that correct?
Yes, sir.
Everywhere the force would be same. So this is what I'm trying to mean over here. This support point is perfectly rigid. So whenever you are applying W load over here, this spring would essentially experience the W load all together. So as a result, this spring will undergo an extension of X. So what's going to happen? This is going to come down by a level of X. So if this was your original level, and this is the new level of the top spring, this one should be X. Now comes the second point. Earlier, the starting point of the second spring was here. Now it has already come down by a value of X. So the second spring will now start from here. And because the W load will still apply on this load as well, because this W load is working along this line and on the entirety of the structure, So this load will also extend the second spring by another X amount. So this will also have, if this was the original length of the whole spring, second spring, this second spring will also extend by X. They'll both extend by X, and as a result, the total amount of extension under this thing would be 2X, because each individual spring would be subjected to the W load. It will not be lessened by each other. On the other hand, let me show you the parallel one, then I'll take questions. Don't worry, I'll answer your questions, confusions as well. On the other hand, if we have a parallel combination, let me show you this with, let's say, red. Let's say we have a situation like this. We have two, this is a solid support system, ceiling maybe. We have two of the springs placed side by side, and we have a support system over here. Let's assume the weight of the support system is 0, and we apply the W load over here. This W load, because this is now being added on two springs side by side, would be shared between these two springs. So this will share half the load, this will share half the load, because together they have to support W load. So this will be pulled down by an individual W by 2. This will be pulled down by an individual W by 2. So this will have an extension of X by 2, which I should show in a different figure. Shouldn't draw this on the same figure. So in this case, this will come down under the effect of W by 2 force, because W was proportional to X. W load gave us X extension. So if we have half the load, it will extend by also half. So it will come down by X by 2. And the second spring will also come down by X by 2. So this was the original level of the two springs bottom. Now the new lower level should be X by 2 below the original level, under the effect of W load. So in altogether sense, how much did the total extension of the whole combination is that? What is the total extension of the whole combination? Is it X by 2 plus X by 2 X, or is it only X by 2? How much longer did the combination get?
Only X by 2.
Asif, তোমার question answer to পড়াইছি. Here the two extensions happen side by side. So the total extension of the combination would be only X by 2. You don't have to add them up, because they did not happen along the same line, which happened over here. Another easier similarity that I can give you is like this. Let's say we have a drum on over here on the ground.
rolling on its side. Not so this is the ground. Let's say a person comes in, pushes it by 1 meter, and then another person comes in and pushes it by another 1 meter. The total movement of this drum would be 2 meter. That's one way. In a different case, let's say we have another drum over here, and two persons comes in on two sides, and they both push the drum by 1 meter. What will be the total movement of this drum? Should it be 2 meter or should it be 1 meter?
1 meter.
It would still be 1 meter. They are both pushing, so they are individually pushing by less force, exactly half the force for what happened over here. But they are both pushing the drum by altogether 1 meter. So this is what is happening for the parallel case. This is basically what is happening for the series case. So whenever the springs are connected in series combination, the load would be applied for all the individual layers. For example, I mean by the word layer, I mean this is one layer, this is another layer, and the extension will happen for both of them. And whenever you have them in parallel, the load will get shared between the parallel combination parts, and as a result, the total extension will become less. So this is just a basic way to show how this works. If we had more springs over here, it could simply become more. For example, if we had 3 springs in series, the total extension would become 3x. If we had 3 springs in parallel, the total extension would become x by 3, because then the load would be divided in three equal ways. That's how the combination works. Now I'll take questions. Anyone? Asif, yes. Obik, bolo.
Sir, for springs in series, shouldn't the first string stretch a little more as it is supporting the weight and another spring with it?
Well, yeah, beautiful question. For the sake of simplicity, we're considering the springs have negligible load or weight of their own. The only load, only force that is making them to go under extension is the W. We are considering the springs themselves have negligible load for the sake of simplicity. But the answer to your question is yes. In a practical scenario, the above spring would always have more extension compared to the lower one. আরেকটা কি জন্য হাত উঠাইছিল, হাত নামায় ফেলছো?
Same question.
Beautiful. To be honest, this is the same question.
Man asked me a question. Will the mass of the springs affect the extension anyhow? In reality, yes. But for the sake of simplicity for your syllabus, we would not consider that it would have any measurable effect. In reality, yes means that if you have a pretty long spring and if you hold it from a pretty tall structure, you'd always see that the top part of the coils are more separated compared to the bottom part of the coils. What I mean is that if you have a pretty, let's say slinky, if you have a slinky, a very long spring would appear to be like this, like big gaps on the top and then slowly smaller gaps at the bottom because of the own weight of the spring itself. This is supposed to happen. This actually happens in reality. But for the sake of simplicity, a complexity ta tomader O levels e introduce kora hoy na, so you don't have to bother about that. So that's pretty much it for today's class. I'll stop the lecture here and we'll pick up from this point and go further down with Elasticity chapter. You can try out the questions in your worksheets. If you have any question, you can also post them in the next class. And of course, we're gonna do transistors in our next class. And if we can finish it within the time frame, we're gonna start some revision of the earlier topics. And I hopefully will be able to post the duration of time of the day when you can send someone or be here to pick up your P4 booklets. Thank you very much. Good night.
Sir, what is the day, sir? Picking up booklet.
I'll inform you in the messenger chat. Don't worry.